So here we have basics 3 practice, not basics 2, basics 3. But so it's a little longer than your quiz will be. Let's just get started. I'll probably have to 2-part this video because I don't have a lot of time for the next class. But let's just jump into it. The opposite of subtracting 8 is adding 8. So if we add 8 to negative 3, we get 5. The opposite of multiplication is division, kids. Some of us need to figure out our opposites, and x is 1. Number 2's got lots of ways of doing it. There's no real wrong way of doing it, but I always like to play the isolation game. So I'm going to subtract 4, and 12 minus 4 is 8. And you didn't have to do that. It just made sense to me to do it. You can either divide the 2 out here because 8 is divisible by 2, or you can use what's called the distributive property. Most people are going to do the distributive property. 2 times 3x is 6x, 2 times negative 8 is minus 16. Still equal to an 8. The opposite of subtracting 16 is adding 16, and 8 and 16 makes 24. The opposite of multiplication is division. Divide both sides by 6, and x is not 6. X is 4. Not too hard. All right, number 3, what do we have here? We have some x's on both sides. We have some numbers on both sides. Just shift your x's one direction. Left is going to be negative 5x minus 9x. The right-hand side is going to be negative 17 minus 9. Now, if you're at negative 5 and you take away 9 more, you're at negative 14x. I know some kids struggle with that. If you're at negative 17 and you take away 9 more, if you're counting left, you're at negative 26. Now we're going to divide both sides by negative 14, and then we're going to simplify the fraction. So negative 26 over negative 14 is what I'm working with. Obviously, a negative over a negative is a positive, and 26 and 14 are both divisible by 2 last I checked. 13/7. All right, moving forward, before we got the bane of your existence here, the absolute value equations. First step in solving an absolute value equation is quite simple. Isolate absolute value. So I am going to add 4 to both sides. 2 absolute values of x plus 5 is a 20, and then I'm going to divide. You can actually distribute inside the bars too with absolute value. But anywho, 2's cancel. 20 over 2 is 10. Notice I did not divide the 5 by 2 because it happened here. That was 2 of these things. Plus they're in bars, you don't have access to it. And we end up with x plus 5 is 10. The absolute value of x plus 5 is 10. Well, now what we're going to do is we're going to write our 2 equations. One of the equations is as is without the bars. The other one, we change the sign on the stuff inside. We take away 5 on the first equation. 10 minus 5 is 5. There's an answer. We add 5. Negative x is 15. Then we divide out the negativity in our life, and x is also negative 15. You'll notice they're not the same number. They're not. All right, there's some ACT practice off to the right on this page as well. When x is 1/3, what is the value of x? You are literally supposed to take that 1/3 and you are supposed to plug it in everywhere you see an x. Of course, you're going to have to do some basic math here. 3 times 1/3, 3's cancel. All right? This is 1 minus 6 sitting over 1/3. 1 minus 6 is negative 5. 5th grade math. To divide by a fraction, we multiply by its reciprocal. And negative 5 times 3 is negative 15. Number 2, in the standard xy coordinate plane, what is the midpoint of the line segment that has endpoints 5, 10, and 1, negative 4? And I'm just going off the side here and looking at this reference sheet. And it is on there. Like, this form is literally on your reference sheet. Which is taped to your desks, kids. It is taped to your desks. But anyways, midpoint is pretty simple. It's literally x1 plus x2 over 2, y1 plus y2 over 2. So we're going to take our x's, we're going to add them together. It's 5 plus 1 over 2, comma, 10 plus a negative 4 over 2. And then we just do math. We're finding the middle of 2 numbers. It's not that hard. Add them together, divide by 2. 5 plus 1 being 6, 6 over 2 being 3. 10 plus a negative 4 also being 6, 6 over 2 being 3. Easy peasy, lemon squeezy. All right, 5 says, PSU, yes, you use what's called the zero product property. Do not FOIL this out. The zero product property is exactly that. It says if the product of two or more things is 0, then one or both must be 0. If the product of two or more things is 0, then one or both or all must be equal to 0. This is called the zero product property. You hear me say ZPP constantly. So you've seen this before. You all have an Algebra 1 credit, otherwise you wouldn't be in here. So by ZPP, 3x minus 4 must equal 0, or, not and, or x plus 2 must equal 0. All right, we're going to add 4. Make sure that you can do two-step algebra. We're going to divide by 3. If you can't do two-step algebra, you probably need to be working on that. That's a two-step equation. Here we're just going to take away 2. So our two answers were, and I know that's hard to see, and some of y'all really struggle reading handwriting. 4/3 is one answer. -2 is the other one. Number 6. 6 is a skill that at best 25% of all kids in the state of Tennessee can master. Isolating a letter. So our goal here is to eventually isolate this R. And we're going to do things in reverse order of PEMDAS. So like your PEMDAS, you do parentheses, exponents, multiply, divide, add, subtract. The easiest thing here, according to PEMDAS, to fix is division of 3. We're going to 3 both sides, or just 3 the whole thing, because that'll cancel out the division. There we have 3b. Here we think 3 times 4/3, the 3's cancel. That equals 4 pi r cubed. Now this is read 4 times pi times r cubed. Our goal is to get this r by itself. Next move, divide both sides by 4 pi, because the opposite of multiplication has always and always will be division. So 4 pi is r cubed. Final move is to fix cubing. The opposite of cubing is to take the cubic root. And I don't know why this has turned into such a hard thing for kids in the last couple of years, but the opposite of cubing is taking the cubic root. Duh. I mean, come on, kids. It's not rocket science. But that's a 3. That's called cubing. We're going to take the cubic root of both sides. Notice I'll put a little 3 here. What happens is those guys annihilate each other. So it turns out that the cubic root of 3b over 4 pi's is r. Now you might also see this written using exponent notation. 3b over 4 pi to the 1/3 is r. I'll probably stick with cubic root for now. I will, because that's more familiar to you. And some of you are like, I don't know what a cubic root is. It's because you can pay any attention, man. 3 cubes, 27. Cubic root of 27 is 3. Like, it's been done with you. Anywho, moving on to 7, 8, 9, 10, 11, 12. 7, 8, 9 kids historically do well. It's here for those who just never quite figured out Algebra 1. This is called the distributive property. We distribute a 3x into both pieces. That's done through multiplication. 3 times 4 is 12. X times x is x squared. Always has been, always will be. 3x times -2 is -6x. Number 8, you guys would do FOIL, or maybe the box. I'll do the box on 9. X times x is x squared. X times 7 plus 7x. -2 times x is minus twice x. And -2 times 7 is minus 14. Combine like terms. You can put those together. They are both apples. Add them together. 7 minus 2 is 5. Number 9, it's worth showing. A lot of kids, probably about 15% of the student body, you can't FOIL. You can't do the double distributive property. I don't know why you can't. I just know you can't. I'm not hating on you. I'm just saying I just know you can't do it. Try drawing a box. 3x times 5x is 15x squared. 3x times -3 is minus 9x. 5x times 8 is 40x. 8 times negative 3 is minus 24. And you'll notice the cool thing about the box is your like terms are along the diagonal. Put them together. 15x squared plus 31x minus 24. Of course, I like the FOIL method. Now, there's a meme back there on the board. It says, what would Jesus do? Jesus would foil the devil's plans. Not pushing beliefs on you. Not just saying. All right. Moving on down here below. Hey, it's our favorite F word, right? Factoring. Our favorite F word. So on number 10, it's simple. It's supposed to be simple. Hopefully you understand some of the understood now, but since there is an understood 1x squared, we focus on factors of C that add to B. Now I'm using letters here, acting like you know something. You are supposed to know when you enter Algebra 2 what's called STD form of a quadratic. It's ax squared plus bx plus c. So a is 1, b is negative 7, and c is 8. Now, are there factors of 8 that add to 7? They are if you think about signs. So I know that 1 times 8 is 8, and I know that 8 minus 1 is 7. Therefore, think about our factoring. Every trinomial has a double set of parentheses. To create x squared, you need an x and an x. Factors of 8, 1 and 8. My math over here. 8 minus 1 is... Milbrath had a brain fart, didn't he? I needed a negative 7. 1 minus 8 is negative 7. So let's redo that. Had a different problem in my head apparently. I need the 8 to be negative and the 1 to be positive. And that doesn't work. You know why this doesn't work? Because this one, as it's written, does not factor, which means I need to change the problem. So I'm going to do that before. Make that a negative 8. So let's go through this again. I know that I know that positive 1 times negative 8 is negative 8. And I know that negative 8 plus 1 is negative 7. So I need to fix that before you guys get this sheet of paper, and I will. But it's x plus 1, x minus 8. All right, number 11. Now, 11 is a trinomial, and the first thing I notice in 11 is that all 3 pieces are divisible by 5. So the first step in factoring is to factor out something small. I can pull a 5 from both pieces. 5 times x squared is 5x squared. 5 times negative 3x is negative 15x. 5 times negative 4 is negative 20. And now what's beautiful is I have created a situation similar to number 10. You need to leave the 5 out front. To make this x squared, you need an x and an x. Factors of 4 are going to be 1 and 4. To add to negative 3, negative 4 plus 1 is negative 3. Beautiful. This is called guess and check, but I'm not really guessing at this point in my life. Number 12 is unique. 12 is actually what we call a perfect square. I have talked about this in class. You can always add 0 to anything. You can. There's a pattern for these, but I'm not going to teach the pattern for a while. But if you throw that 0x in the middle and think about the foiling, you might get there. To make a 9x squared is probably going to be a 3x and a 3x, because 3 times 3 is 9, x times x is x squared. Factors of 16 that add to 0 are plus and minus 4. And like I said, there's a pattern here, but thinking about some of the kids I've got, I don't want to talk about patterns yet, because that makes it harder for them. And I got to be done in 2 minutes, so I think I'm at a good halfway point. So there's the first part of this video. Obviously, when I get some more free time, I'll do another part of the video as well. So there's a little over half that sheet done for you.